Hello, everyone. A very good morning, afternoon, and evening to all. Dear authors and invited guests, we welcome you to the technical session 9F. My name is Anisha, and this session would be moderated by me on behalf of Global Knowledge Research Foundation and GR Scholastic LLP. It is my great pleasure to welcome you all to the 4th World Conference on Information Systems for Business Management, ISBM 2025, Bangkok, Thailand. The 4th edition of the conference is being organized in a hybrid mode. The physical event was held in Bangkok, Thailand, and the virtual event is being held through Zoom yesterday and today, that is 25th and 26th of September 2025. I hope you all will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. And on 9 minutes, I'll be raising a gentle reminder. There's also another request to all the participants to please stay connected with us till the closing of the session. And if you have any query or update, you can write it to me in the chat box. So before we start with the session, I'd like to introduce you all to the chair for this session, Professor Zlatinka Kovacheva. She's a professor at the Institute of Mathematics and Informatics, Bulgarian Academy of Sciences, Oman. Her research focuses on mathematics, information systems, OLAP neural networks, and data mining. With extensive teaching experience in higher education, she specializes in automatic system for data processing and management, contributing to advancements in computational and analytical methodologies. We welcome you to the session, ma'am.
Thank you very much, Ms. Anisha.
Yes.
I'm very pleased to be invited to chair this session. I hope that it will be very successful for all participants to share our ideas, our research, our vision on information systems and their development for business management. I request all participants to follow strictly the rules, and presentation should be no more than 10 minutes because we need at least 2 minutes to discuss and to answer the questions.
Right.
Thank you again, and we have to start our session with the first presentation, Efficient Car Logo Detection via YOLO V8 and Attention Mechanism Fusion. Please welcome Mr. Nguyen.
You can start sharing your screen.
Good afternoon, everyone. Today I present our research on efficient car logo detection using YOLO V8 and attention mechanism fusion. And this work was conducted by FPT University Cần and focused on comparing different lightweight attention mechanisms for real-time car logo detection in intelligent transport system. And the next research contribution, our study makes 4K contribution. First, we provide the first comprehensive comparison of ECA, CMAM, and their combination specifically for car logo detection. Second, we conduct systematic evaluation across multi-dimension, not just accuracy, but also computational efficiency and inference speed. Thus, we demonstrate that attention mechanism and enhance performance while maintaining real-time capability. Final, we offer practice selection guidelines based on the deployment constraint. And the next, attention mechanism overview. And let me introduce the attention mechanism we study. It's a U efficient general attention rule 1D convolution with adaptive kernel size and providing minimal parameter overhead. And SIMAM is completely parameter free using Norrod's time is by energy function to evaluate eval- evaluate neuron important. Our combined plus strategical interarray both mechanism in the backbone and hit section for comprehensive future enhance. Uh, in iteration strategy for fair comparison, we use unified iteration strategy for individual mechanism. Attention module we play after C2F block in the detection hit at B3, B4, and B5 scale. And this enhanced multi-scale feature critical for logo detection without altering backbone semantics. The combined approach use alternating ECA and CMAM the backbone and in the heads only ECA module. The next experimental setup, and we use the global flow car logo dataset with 5,372 images, while smaller than large-scale dataset is suitable for evaluating attention mechanism in vibrant touch. Training use standard ULOVA configuration 640 inputs and exercise sitting 130 epoch and RMW optimizer. We evaluated on NVIDIA RTX 4090 CPU, measuring accuracy, efficiency, and real-time performance metrics. Here are the main performance results. The baseline YOLO VA achieved 95.2 MAB 0.5 and SIM AM achieved the highest MAB 0.5S 96.1 and battery con at 93.7. It's a excel in precision with 96.9 and MAB at 50.2%. Finally, the combined approach provide balanced performance. Importantly, on attention mechanism improved upon the baseline, validating their effectiveness even with limited data. And the computation efficiency, well, regarding computational efficiency on model maintain real-time performance above 25 FPS and ACA. So the best inference at 29.29 FPS with minimal parameter overhead. Both ACA and CMM reduce the plot from 79.3 to 79.1, and this demonstrate that lightweight tension mechanism can enhance performance without sari- sacrificing real-time capability, and crucial for prax- practical practical deployment. And about qualitative analysis. Our qualitative analysis on real traffic said effective align with one quantitative result. The baseline detects various logo with two logo and consistent is lowered recall with SIMA AM. So the more detection but more phone positive, and patching is high recall but slightly lower precision. And the PCA with N, the combined model produce more reliable detection, reinforcing the superior precision score. Uh, the next practical guideline based on our analysis. Here are the practical selection guideline, and should say if the precision is your main objective, fast inference is required, or minimal model size is desired, and ideal for latency sensitive application, or choose SIM-AM if the maximizing recall crucial, some precision loss is acceptable, or zero parameter overhead is required. And the combined approach offers parametric burst at complexity without signal significant benefit over individual mechanism. In conclusion, in conclusion, on mechanism output outperformance by ULOVA while maintain real-time performance. We demonstrate effective enhancement even with a limited dataset of over 5,000 images. And SIM-AM is the best recall critical task, while the ECA offer optimal precision speed trade-off. And this will provide first systematic comparison of level tension mechanism for carrier detection, offering clear guidance for deployment. And thank you for listening.
Thank you very much. Are there any questions or comments or recommendations? Please, can you tell us about something about the experiments which you did? You showed us some picture, but can you tell us how long time the system was tested and when and where? Yes, I saw it. But how long time was the test?
I testing what time?
I mean, how long did you apply the system? For 1 day, for 2 days, 1 month, 1 year?
Okay. Can you repeat the question?
We see the pictures, yes, but my question is, how long time your system was used? Okay, no problem. Let us go to the next presentation.
Sure.
Yes, the next presentation.
Thank you for the presentation. So,
Empowering auditor
Luckily,
performance.
we have another session chair with us. She has joined the session now. I'll just. Yeah, so we have Dr. Vijita Kumawat with us. She's a professor and head of the Department of Computer Science and Engineering at Jaipur Engineering College and Research Center with 17 years of teaching experience. She holds 2 Indian patents and has expertise in ad hoc networks, wireless sensor networks, and the Internet of Things. She has authored 5 national and international publications and participated in more than 50 seminars and workshops. So we welcome you to the session, ma'am. And yeah, now we'll be moving forward to the presenters. And the next presenter is Windy Parmata Suyono with the paper title Empowering Auditor Performance Through Digital Access and IT Infrastructure, the Mediating Role of Auditor Competence.
Yeah, I already miss. Okay. Good afternoon, ladies and gentlemen. My name is Windy Permata Siono, and today I'm honored to present my research entitled Empowering Auditor Performance Through Digital Access and IT Infrastructure, the Mediating Role of Auditor Competence. The study explores how technological enablers and human skill to improve audit effectiveness in the era of digital transformation. An introduction. In recent years, the auditing profession has undergone a digital shift. Cloud computing, big data analytics, and artificial intelligence are reshaping audit process. However, technology alone is not enough. To ensure high quality audit, organization need not only digital access and strong IT infrastructure, but also competent auditors who can apply judgment and analytical skill. The study is grounded in the Technology Organization Environment Framework or TOE and Research-Based View or RBV, aiming to examine how technology and competence jointly enhance auditor performance. And then research gap and contribution, limited empirical evidence on interaction of human and technological factors in audit performance, insight for audit training, capability development, and digital strategy alignment. Okay, need later review. Auditor performance is increasingly critical for accountability and transparency. Digital access enable continuous auditing, anomaly detection, and real-time analysis. IT infrastructure provides reliability, scalability, and integration, but weak system creates silos and inefficiency. Auditor competence, covering technical skills, ethical judgment, and digital literacy, acts as the moderate mediator linking technology with performance. And then theoretical lens, the theory of framework explain the readiness from a technology, organization, and environment perspective, while the TTF theory emphasizes that the performance improves when technology aligns with human tastes and abilities. And based on this review, we developed 7 hypotheses. And the first, hypothesis 1, digital access has a positive effect on auditor performance. And hypothesis 2, IT infrastructure has a positive effect on auditor performance. Hypothesis 3, auditor competence has a positive effect on auditor performance. Hypothesis 4, digital access has a positive effect on auditor competence. Hypothesis 5, IT infrastructure has a positive effect on auditor competence. Hypothesis 6, auditor competence mediates the relationship between digital access and auditor performance. And the last hypothesis, auditor competence mediates the relationship between IT infrastructure and auditor performance. In the research method, this study applies a quantitative research using structural equation modeling atau SAMPLS. We survey 110 professional auditors from both public and private institutions in Jakarta and West Java using purposive sampling. Respondent had at least 1 year of experience and exposure to digital tools such as audit software, cloud system, or data analytic construct. Digital access, IT infrastructure competence, and performance were measured with validated scales on a 5-point Likert scale. We analyzed the data using SmartPLS 4.0, applying bootstrapping with 5,000 resample, reliability and validity tests confirm the robustness of the measures, and ethical principles such as informed consent and confidentiality were observed. Okay, result and discussion. Convergent validity. Convergent validity. First we test convergent validity and the left picture as shown in the PET diagram. All factor loading are above the acceptable threshold 0.7, indicating that the items consistently represent their construct. Next, we examine discriminant validity, which access whether the construct are distinct from one another. In table 1, we can see that the square root of EV value on the diagonal are higher than the correlation between construct. This confirms that digital access, IT infrastructure, auditor competence, and auditor performance are empirically distinct and valid for further analysis. And the next, moving on to construct reliability and model quality. Table 2 presents the result for conference alpha, composite reliability, average variant extracted, and all value exceed the recommended thresholds. Alpha and composite reliability above 0.7 and AV or average variant extracted above 0.5 confirm that the construct are reliable and valid. Table 3 shows the R-square value. Auditor competence has an R-square of 0.637 and auditor performance has an R-square of 0.611. Both are categories as a moderate explanatory power. This means our model explains around 63% of the variance competent and 61% of the variance in performance, which is considered acceptable for social science research. This result confirms that our measurement model is both reliable and valid, and we can confidently process to hypothesis testing. And then direct effect testing result. Bootstrapping with 5,000 resample were used to evaluate PET coefficient, SA, p-value, t-value, and confidence interval. A hypothesis is accepted if test statistic more than 1.98 and p-value less than 0.05. The result revealed interesting patterns. The first, digital access has no significant direct effect on auditor performance. IT and the second, IT infrastructure positively influence auditor performance, and the third, auditor competence strongly enhance auditor performance, and the fourth, digital access significantly improves auditor competence, and the five, IT infrastructure or IT shows the strongest effect on auditor competence. Okay, the highlight that competence is the critical element linking technology with actual outcome. Okay, indirect effect testing result. Bootstrapping with 5,000 resample were used to evaluate PET coefficient, SA, p-value, t-value, and confidence interval. And then auditor competence tested as a moderating variable. Hypothesis accepted if test statistic more than 1.098 for and p-value less than 0.05. When the we then test mediation patch and then digital access auditor competency significantly mediates the effect of digital access on auditor performance and the means HANAM accepted. IT infrastructure positively influence auditor performance indirectly via improve auditor competence and the means hypothesis 7 accepted. Okay. In the discussion, our finding emphasizes that auditor is the strongest driver for audit performance. IT directly improves effectiveness by ensuring that audit tasks and are executed properly. Digital access contribute to performance, but only indirectly through competence. This means that technology by itself is not enough. It becomes valuable when auditors have the skill to apply it effectively. We also found that IT infrastructure plays a dual role. Indirectly, it strengthens competence development and amplify its impact on performance. At the same time, it has a direct effect as reliable infrastructure independently enhance performance. Overall, the result highlight a synergy, auditor competence, digital access, and IT infrastructure together critical enablers of performance in today's digital audit environment. Okay. And the next implication, theoretical strengths the digital audit literature by linking competence, infrastructure, and performance. And the practical audit institution should invest in IT system and training. Policymakers should design capacity building program. Organization must align technology with audit text. And the limitation, sample restricted just 110 auditors in Jakarta and West Java. Cross-sectional and self-reported data might cause bias. And then futuristic broader cross-country studies, longitudinal approach to capture transformation over time, explore moderating variables such as organizational culture, digital mindset, or regulation, possibly using mixed method. And the last conclusion, to conclude this study show that auditor competence is the key bridge between technology and performance. Investing in digital access and IT infrastructure will only yield result if auditors are equipped with the right skill. For emerging economics like Indonesia, a human-centered approach to digital transformation, focusing on both technology and competence, is vital to enhance accountability, transparency, and audit quality. Okay, thank you for your attention. I look forward to your discussion. Okay, thank you. Miss Anissa, can you hear my voice clearly? Okay, Miss Zlantika.
I think that we don't have time now for more discussions. And we can go of course, if there are no questions. If there are questions, please.
Well, I think there are no questions. So thank you for the presentation.
Okay, you're welcome, Miss.
Yes, now we will be moving forward to the next presenter. We have S. Manvita Reddy with the paper titled Fine Tuning Bar for Multi-Label ICD-9 Prediction from Clinical Discharge Summaries. You can share your screen now and start presenting.
Miss, sorry, I would like to move to another session room as I need to attend other presentation in this ISBM conference in the room, in the another room. Can
Okay.
I leave? Sorry,
Yeah, okay, no worries. Yeah.
I want to presentation again in the next room. Okay, thank you, Miss.
Good afternoon, everyone. I'm Sura Manvita Reddy. Today, I'll be presenting our project titled Fine-Tuning BART for Multi-Label ICD-9 Prediction. So the main goal of this work is to automate ICD-9 coding from clinical text using advanced transformer architectures. Our model is designed to handle long and noisy discharge summaries while still delivering accurate multi-label predictions for real-world clinical applications. So assigning ICD-9 codes to patient notes is very important, but it's also very complex. So first is scale complexity. There are thousands of diagnostic codes, often organized hierarchically, and understanding which one fits requires deep clinical expertise. And the second one is language variability. Doctors don't write notes in the same style. They use abbreviations, medical jargon, and narrative differences, which make automated processing difficult. The third is the multi label nature. Most patients require more than one code at the same time. For example, a single discharge summary might need codes for diabetes, hypertension, and pneumonia. So the challenge is dealing with a huge number of codes, inconsistent language, and the need for simultaneous prediction. So now let's look at the previous approaches that were done and why we need to do something new. Rule-based systems were tried, but they didn't scale across diverse clinical settings. CNN and RNN based models were better, but they can only capture short range information and can miss dependencies across long nodes. Transformer-based models like BERT and clinical BERT improved performance, but they are encoder only. This means they truncate long discharge summaries and lose important context. So here, the gap is clear. We need a model that can handle long clinical narratives, capture dependencies across the entire document, and can still generate structured multi-label outputs. So our solution is a BART transformer. So to solve this issue, we used a BART, a transformer with both an encoder and a decoder. The encoder reads the text bidirectionally, understanding which will understand the entire discharge summary in the context. And the decoder generates outputs step by step, which allows us to treat ICD-9 prediction like a translation problem, where it translates free text notes into medical codes. And most importantly, BART captures both global meaning of the document and the fine grained cues, such as whether the patient has type 1 or type 2 diabetes. This makes BART very suitable and very suited for the task compared to encoder only models. So for this research, we used a stimulated data set modeled after the Mimic3 clinical database. The original Mimic3 is a real de-identified hospital dataset widely used in research. However, since it contains sensitive data, we worked with a stimulated sample version that mimics its structure and characteristics. This dataset contains discharge summaries paired with ICD-9 codes. To keep the task practical, we focused only on the top 20 most frequent codes. So we split the dataset into 80% training, 10% validation, and 10% for testing, ensuring a fair and robust environment. So for data pre-processing, before training, we applied pre-processing to clean and to prepare the data. So first for noise removal, we removed placeholders, extra symbols, and standardizing terms. Then for tokenization, we used BART's byte pair encoding tokenizer, which handles rare words and abbreviations in clinical notes. And the length optimization. Since notes are very long, we truncated them to the first 1024 tokens, which typically covers sections like chief compliant and hospital codes. Label encoding, each ICD-9 code was converted into a binary vector, making the task a multi-label classification problem. This pipeline ensures the model
BERT or
works.
GPT for I.
So our model is based on BART large, which has 12 encoder layers and 12 decoding layers. On top of this, we added a linear classification head with 20.
Excuse me, Sura, I wanted to ask you one question.
Yes, ma'am.
Yes, listen to me.
Yes, ma'am.
Uh, yes. Yes, my voice is audible.
It's breaking. I'm not able to hear properly.
Yes.
Hello.
Yes, Sura, I'm talking.
Yes, ma'am.
Yes, I'm audible.
Yeah, right now you're audible, ma'am.
Yes. I want to ask some question like why did you choose BERT over other transformer model like BERT or GPT for ICD-9 prediction?
Um, mm,
Yes, anyway, continue your presentation.
okay. So our model is BART large, which has 12 encoder layers and 12 decoder layers. On top of this, we added linear classification head with 20 outputs, one for each ICD-9 code. We used a sigmoid activation so that the model can predict multiple codes at the same time. For training, we used Adam W optimizer for binary cross entropy loss. To make the training efficient, we applied mixed precision, gradient accumulation, and label smoothing. This allowed us to train the model on large data without losing performance. So now let's look at the results. Our model achieved an overall F1 score of 0.71, showing a strong balance between precision and recall. When we look at specific codes, diabetes scored best with an F1 score of 0.61 because it has consistent medical descriptions. Essential hypertension had a moderate F1 score of 0.57. So it is, as it is often described as a subtler terms. Affective psychosis was more challenging, which scored an F1 score of 0.49, since psychiatric conditions are described in more variable languages. We also checked for ROC and AUC scores, which confirmed the model can handle imbalanced codes, performing well on both frequent and less common diagnoses. We compared our models with other established approaches. CNN-based models like CAML scored around 0.54. Transformer-based models like Clinical BERT scored around 0.75, but it struggles with longer nodes. Our BART model achieved 0.71, showing that the encoder-decoder architecture is more robust for handling long and noisy clinical narratives. So, while not being the absolute highest, our approach strikes a good balance and shows strong potential for real world deployment. In summary, our BART model demonstrates robustness against noisy, lengthy clinical narratives, also gives a balanced coverage, performing consistently across both frequent and rare codes, with clinic and also clinical reliability with stable precision recall behavior needed in healthcare decision support. Thank you. Any questions?
Well, I believe there are no questions. So, yeah, thank you for the presentation.
Thank you for letting me present.
Moving forward in the session to the next presenter, we have Mahima Been Punjabi with the paper titled Formative Assessment of Spoken English Using Large Language Models in a Controlled Intervention Study.
Hello, I hope I'm audible.
Yes, you are audible.
Okay, is my screen visible?
Yes.
Let's think for a moment about your most anxious student. The one who has great ideas but freezes up the movement they have to speak in front of the class. What if you could give that student a private and patient tutor available 24/7 to help them practice and build confidence without any fear of judgment? This isn't scientific fiction. This is the possibility we set out to explore. Good afternoon, everyone. My name is Mahima Punjabi. And on behalf of my guide, Dr. Vijay Makwana, and myself, I'd like to thank you all for being here today. We are from Charutar University of Science and Technology in Gujarat, India. Today, we are excited to present our research on a topic of growing importance in language education, that is formative assessment of spoken English using large language models. As language educators, we all understand that developing spoken proficiency is a primary goal for our students. However, we also know the challenges involved. Traditional methods of formative assessment, while they are very effective, but they are incredibly resource intensive. Providing personalized, timely feedback to every student is a monumental task. We all are there. Furthermore, over time, it has been observed that the very act of being assessed can create significant speaking anxiety, which hinders a student's ability to practice authentically. This creates a bottleneck in the learning process. This brings to the promise of new technology, the emergence of powerful large language models, or LLMs as we call them. They offer a potential solution. So they can provide instant, on demand feedback in a private, non judgmental environment. But as researchers, we know that promise isn't enough. There's a critical need for methodologically sound research to validate the effectiveness. This led us to our central research question: just how effective are these tools for assessment? To answer this, we designed a mixed methods of study. We worked with a group of 30 intermediate ESL learners. All students compiled a pretest and then engaged in a weekly speaking practice using LLMs, and finally completed a post test. To get a complete picture, we didn't just look at that test score that we were having. We analyzed the AI generated feedback. We read students' reflection logs and interviewed 5 faculty members as well. To ensure the highest level of rigor, we also had human experts evaluate the students' speaking test uh, and how they are speaking after the learning part. It allows us to compare the AI assessment and a human benchmark that we have. So, what did we find? First and foremost, the quantitative results were very clear. There was a static improvement in students' speaking proficiency after the 12-week intervention. Weekly intervention. We observed a strong gain in their overall score and specifically in their grammatical accuracy and use of vocabulary. Now, this tells us that interaction with LLMs and it had a tangible and positive, impact on their linguistic skills. But again, raw scores won't tell us the whole story. So when we compared the AI feedback to that of our human experts, again, another fantastic pattern emerged. The LLMs were highly accurate and they identified discrete rule-based errors, things like grammar mistake and vocabulary, uh, the choice of vocabulary instead. So the performance here was very close to our human coders. However, they struggled with nuances of language. They were very inconsistent in interpreting expressions of and often missed subtle and context dependent pragmatic errors as well. The kind of social appropriateness that a human listener understands better. Our qualitative data from students and faculty strongly reinforced this distinction. Students loved the LLMs. They felt that it created a safe and low stake environment where they could practice without fear of judgment. This reduced their anxiety, and as a result, they practiced more often. Faculty also saw immense value. They noticed that the AI could handle the time consuming task of basic error correction, freeing them up of focus on more complex skills during class time. But the consequences were uh, unanimous. So these tools are best seen as a support system for a teacher, but not a replacement. So uh, what does all these mean uh, for us as educators? Our research strongly supports our hybrid pedagogical models. In this model, we leverage technology for its strength. We can use LLMs, we can use them as a tireless digital assistant to provide students with endless opportunities and for practice and immediate feedback that again, this enhances learners' autonomy and engagement outside the classroom. Now, this in turn frees the human educator to focus on their uniquely human strategical communication and fostering the interpersonal connection that is so crucial to learning. In conclusion, our study provides strong evidence that LLMs can be powerful aid in our teaching toolkit. They are not a silver bullet, but when integrated thoughtfully into a hybrid model, they can significantly enhance learning experience. Of course, our study has its limitations, including the lack of control group. Future research should build on this work with larger and more diverse sample and controlled trials. That brings me to the end of my presentation. Thank you so much, everyone, for your time. And I would like to be happy to answer any questions if you may have any.
Thank you very much. Is your research related only to the experience in your university, what you did, or also in other places?
not only my university, but in Gujarat, yes, not only my university.
Yes, thank you.
Thank you for the presentation. We'll be moving forward to the next presenter. And we have Raghavan Vaidyanaraman with the paper titled Non-Linear Classification on Mini Rocket Architecture for Fish Freshness Prognostics.
Hey, am I audible?
Yes, you can share your screen and start the presentation.
All right, perfect. There'll be two people presenting this research paper. So it'll be
that's all right.
Okay.
Just give me a
Perfect.
second, I'll share it.
Yeah.
Please let me know if it's visible.
Yeah, all right. So, good afternoon to all present here. Today, I, Arivardhan Modi, along with Raghavan Vaidyanaraman from Vellore Institute of Technology, India, will be presenting our work on non-linear classification on mini rocket architecture for fish freshness prognostics. Next slide. So, my talk will briefly cover abstract introduction, mini rocket, literature survey, and the exploratory data analysis that we have done. And we'll close with results and insights. Next. Our goal is to build, so our initial objective was to build a fast, low-cost system to monitor fish freshness using MOS gas sensors. We extract features with mini rocket and test multiple classifiers. Highlight being nonlinear models like random forest reach roughly 90% accuracy, especially improving the tricky semi-fresh class. And why does this matter? As it supports food safety, reduces waste, and enables real-time IoT deployments. Introduction. Seafood freshness is critical for public health and economics. Traditional methods like microbial testing are accurate, but they're very slow and costly. At the same time, time series classification is promising, but deep model are heavy for edge devices. Mini Rocket, on the other hand, offers a light alternative. It's fast, it's deterministic, and it's accurate. We have applied it to gas sensor data MQ135 for VOCs and TGS2602 for amine and sulfur gases, both strong indicator of spoilage. Talking about Mini Rocket applies thousands of 1D convolution kernels to the time series. For each kernel, it computes a simple statistic called PPV, or proportion to positive value. Roughly thousands features are generated within milliseconds. No heavy training is needed. While it's usually paired with linear regression, our novelty is using non-linear classifiers like SVM, random forest, gradient boost, KNN, and MLP, which exploit the hidden pattern, especially for the semi-fish category. This is the initial architecture with rich classification. And then we have non-linear classifier, which are able to easily process for fresh, semi-fresh, and not fresh categories. Coming on to literature survey, Rocket and Mini Rocket are well established for time series classification since they're fast and accurate, but there are variants like multi-rocket, S-rocket, and Hydra, which balance accuracy and cost. Most studies use linear classifiers, but some show that non-linear ones can outperform them. In case of fish freshness studies, electronic noses with PCA or neural networks exist, but they struggle with the middle label, which is semi-freshness. Our work bridges the gap by combining Mini Rocket with nonlinear classifiers for fish freshness. Moving on to our exploratory data analysis, we analyzed a dataset of 27,204 samples from tuna, mackerel, and tilapia stored at 4 degrees Celsius. Each sample is about 120 seconds of reading from two MOS sensors, MQ and TGS. The dataset was labeled by the days of storage, 1 to 3 being fresh, 4 to 7 being semi-fresh, and 8 plus being not fresh. Class balance is slightly skewed, freshness being roughly 35%, semi-freshness around 48%, and not fresh being around 17%. Next slide. From the plots, we essentially understand that there's a steady rise of VOC over time, capturing overall spoilage trend. In TGS, spikes are more sharp with amine and sulfur compound gases strongly linked to decomposition. Together, these sensors give complementary signals which help the classifier separate the freshness stages. We have also noticed that there is an overlap in the semi-fresh range, which is exactly why non-linear models are extremely crucial as they carve out those subtle boundaries between linear ones. Over to Raghavan.
Thank you, Aryavardhan. Good afternoon, respected conference members. As presented by Aryavardhan, our goal is to classify fish freshness may be in fresh, semi-fresh, or not fresh using gas sensors. Our pipeline is like pretty straightforward. We take the raw data ingestion of two signal sensors from the MQ and TGS sensors. And secondly, we pre-process the data by cleaning, and then the mini rocket transforms into fixed length feature vectors. Third, we use the classifier training by using a range variety of models, may it be SVM, MLP, KNN, random forest, etc. And fourth, final one is the evaluation to test the accuracy and to generate the confusion matrix. So for the result, we can see that the linear baseline, which is actually the ridge model which used to be used before, reached an accuracy of 27.6%. But using nonlinear classifiers clearly improves things. Especially with random forest, we can see a 90% of overall accuracy and very, very fast inference. We can see the confusion matrix as well in the left-hand side, where we're having at 88% in the ridge, and as we're going below, the accuracy is increasing to 90%. There might be a question like, why haven't we used SVM? Because that is also giving a good accuracy of 90% almost, or even use the ensemble learning for both random forest and SVM together. But the main reason being the inference time taken by random forest is the same as ridge, which is very, very quick in milliseconds. Whereas in SVM, it takes seconds to process, which might not be ideal for real-time inference. Now, the real question, is it a significant improvement? Yes. So as we can see in this slide, right? For instance, India's total fish production was estimated to be 1.95 million metric tons in the year of 2024 to 2025. So when we're classifying the error, if whatever was supposed to be fresh, if it was moving to, it was showing as not fresh, we are seeing about this many errors, which was reduced in random forest. And if we used this random forest instead of ridge, we could have corrected 70,000 metric tons of fishes wrongly classified. In a different example, semi-freshness was actually classified wrong as non-fresh. If we used it in the year of 2024 to 2025, we would have corrected 60,450 metric tons of fishes. Giving another example, if your non-fresh was wrongly classified as fresh or semi-fresh, we would have corrected 23,000 tons of fishes in the year of 2024-2025. So that's the impact we could have made by using this, and that's how strong our research paper is. Going to the future work, we would like to port mini rocket and random forest to low power microcontrollers, as we expect the current speed to translate well for IoT devices. Add targeted channels, especially NH3 and even H2S sensors, to captivate or to capture the spoilage of chemistry like more precisely, and use SHAP to show patterns that drive each decision. This makes it more transparent, auditable models, reliable and can check whether it's suitable for regulatory environments, and can even help for fine-tuning operations. We can take SHAP as as an example, which is really known right now as XAI, or explainable AI, right? So which actually shows that different decisions, or explains why AI has taken a specific decision or not. That's what SHAP is all about. To wrap up, we have addressed that fish freshness classification using sensors and mini rocket features. We have showed that adding nonlinear models on top of those features delivers meaningful and more efficient gains. The best performer, that is random forest, reaches 90% accuracy, and the system is fast enough for real time and lightweight enough to embed with any IoT real time application. The practical impact is very clear. Fewer false rejections, fewer risky passes, less food waste, and stronger consumer safety. All on a pipeline that's simple to operate, scalable, and ready for embedded deployment. Thank you.
Thank you very much for your interesting and very useful research. I have only a question because I see that you test only the freshness of the fish. Do you
Yes.
plan to test also if the fish is spoiled because of some chemical environment or something like this? Because we know that nowadays the waters are not clean and
Absolutely.
not only freshness but also other factors are important.
Absolutely, as pointed out, ma'am. When we are talking about even the water, if it's going to be a lot, I mean, bad water or anything like that, that's going to affect the chemical composition of the fish. And these sensors, right, whatever we have used, as has actually it takes these chemical sensors into consideration to check whether the freshness is there or not. But now in the future work, we are, as you rightly pointed out, we want to even use especially NH3 sensors and H2S sensors, which could actually detect those whether other factors are spoiling the fish or not. Does that answer the question?
Thank you very much. I really recommend you to continue in this direction. Thank you.
Absolutely.
Thank you so much, ma'am. Thank
Thank you
you.
so much, ma'am. Thank you, everyone. Any other questions?
Thank you for the presentation. Moving forward to the next presenter, we have GGS Pradeep with the paper titled Optimizing Feature Selection for Medical Diagnosis Systems Using Differential Evolution.
Ma'am, instead of Pradeep, I am presenting, ma'am. Sir is on another work.
Okay.
Can I start, ma'am?
Yes, you can share your screen and start the presentation.
Optimizing feature selection for medical diagnosis systems using differential evaluation. Mainly, this study proposes a feature selection framework for medical diagnosis using binary genetic algorithm optimized with differential evaluation. This method addresses challenges of high-dimensional clinical datasets, which often contain redundant features that affect the classification accuracy and computational efficiency. By employing these evolutionary optimization, the framework balances accuracy with dimensionality reduction through a fitness function. This approach integrates pre-processing, binary encoding of features, and iterative optimization. Now, the first is like introduction. Here, medical diagnosis releases increasingly on machine learning for early and accurate disease recognition, especially in fields like cardiology, neurology, and oncology. This is a like mainly this data set is like clinical data set, however, like high dimensional and redundant, leading to poor generalization with high computational costs. Mainly, this is the literature survey. The previous research highlighted the strength of differential evaluation in medical applications. In 2022, they demonstrate its effectiveness in ovarian cancer detection by reducing false negatives. In 23, they used differential evaluation for EEG based emotion recognition, achieving robust performance across subjects. In 2024, they combined differential evaluation with ensemble learning to improve the survival cancer diagnosis. Like validation flows. In 2025, they applied differential evaluation in brain tumor detection with deep learning framework. It's showing like accuracy and efficiency gains. Collectively, these work established differential evaluation as a powerful method for robust feature selection in high-stakes healthcare tasks, motivating and integrating in especially this study. This is like the first is like methodology. Here, like feature selection and classification methodology. Here, like input data set, input data. Here, like feature vectors and target labels. And Next one is data preprocessing. In data preprocessing, jet score normalization, training and testing, and feature selection, binary genetic algorithm, and fitness function. And optimization process at initialization, selection, crossover, and mutation. And the classification and performance here classifier training and confusion matrix. Future stability analysis here like future frequency and histogram accuracy. Mainly like first one is like algorithm processor. The first process start with initializing a random population of future substrates, followed by evaluating their fitness. And the subsets undergoes crossover and mutation to create new candidates, while differential evaluation refines these candidates by adjusting the future vectors. Based on differences among the population members, iteration continual convergence is reached or a stopping criteria. The results and discussion. First one is like best accuracy over generation. Here, convergence trajectory of the optimization algorithm showing rapid early gains in classification accuracy followed by stabilization across the successive generations. And the confusion matrix. Here, performance matrix delineating the true and false predictions for malignant and benign classes, highlighting the model as sensitivity and specificity. And here, three-dimensional scatter plot correlating individual index and the future count and accuracy with color-coded fitness gradients, indicating optimizing efficiency. Now, conclusion, these research presents on effective and interpretable method for optimizing feature selection in medical diagnosis systems using differential evaluation and genetic algorithms. By balancing the dimensionality reduction and the predictive accuracy, the framework enhances sensitivity and specificity while minimizing the computational overhead. The approach is proved resilient against overfitting, delivering stable and clinically reliable results. Now, future work will focus on scaling the framework to larger and the multimodal medical dataset and improving the readability of mathematical expressions for broader accessibility. This contribution underscores the role of bio-inspired optimization in advancing data-driven healthcare solutions. References, the sample references. Thank you. Any questions?
Thank you very much for the very interesting presentation. Actually, how did you apply your technology in what places? In one clinic or maybe more hospitals, etc.?
Yes, ma'am. We can apply anywhere in the mainly in healthcare. We can apply only in healthcare. We can use like different algorithms we can use. Mainly with
Yes,
these,
you can, but my question was where did you test the technology?
ma'am, here we tested like mainly we used in differential evaluation with such efficiency. Mainly we tested here, ma'am.
But you tested in one hospital or clinic or many places?
Yes, ma'am. Different places we tested. Different places. Yeah.
And approximately how many? Or you cannot say exactly.
Approximately like 120 plus, ma'am.
Okay, thank you.
Thank you, ma'am.
Are there any other questions or comments? If there are no questions, I think we can go further.
Yes. So moving forward in the session, we have our next presenter, and then Van, with the paper titled Optimizing Multi-Agent and Functional Architectures for Enhanced Financial Trading Performance, WinTrade Agent Case Study.
Hello, let me share screen.
Yes. Please.
Good afternoon, everyone. My name is Angden Bang, and today I will present our study titled Optimizing Multi-Agent and Functional Architecture for Enhanced Financial Trading Performance, a Vintrade Agent case study. This is joint work with colleagues from the University of Economics and Law and the Business Intelligence Research Lab. About the motivation and problem. Large language models are transforming decision making, but applying them in financial market, especially emerging ones like Vietnam, remains challenging. Our market is highly volatile and has low liquidity and involving regulation. Traditional AI trading systems lack transparency and adaptability here. We aim to build a solution that's not only accurate, but also explainable and auditable for both investor and regulators. About the research objectives, our main objectives is to design a hybrid framework combining multi-agent system and functional architectures. Each agent has a specialized role, like fundamental, technical, news, market, trader, and risk. Together, they interact through debates and risk gating. Our goals are to improve risk-adjusted return and provide explainable decision trails and explore back-office automation use case like report generation. About the Vintrade agent framework, our solution is Vintrade agent, a hybrid architecture. Multi-agent roles are embedded within a structured functional pipeline, from data ingestion to on-flow modeling, risk management, and execution. Agent collaboration in two ways, horizontally through debates between bull and bear perspectives, and vertically where the risk manager supervises final decision. This structure ensures both adaptability and accountability. Assigning LLM's agent clear, well-defined roles with specific goals enable the breakdown of complex objectives into smaller, manageable subtasks. Financial trading is a prime example of such complexity, demanding the integration of diverse signals, inputs, and specialized expertise. In the real world, this approach to managing complexity is demonstrated by trading firms that rely on expert teams to collaborate and make high-stake decisions, underscoring the multi-faceted nature of the task. In a typical trading firm, vast amount of data are collected, including financial metrics, price movement, trading volumes, historical performance, economic indicators, and news sentiment. This data is then analyzed by quantitative experts, including mathematicians, data scientists, and engineers, using advanced tools and algorithms to identify trends and predict market movements. Inspired by this organizational structure, we define a distinct agent role within a simulated trading firm. They are fundamentals analysts, technical analysts, news analysts, market analysts, researcher, trader, and risk manager. Each agent is assigned a specific name, role, goal, and set a constraint alongside predefined context, skill, and tools tailored to their function. About the performance and efficiency, we tested Vintrade agent on 15 representative stocks from banking, financial service, and real estate. Each stock analysis took on average 92.75 seconds and about 88,000 tokens, costly roughly 4 cents per run when we're using GPT-4o Mini. This demonstrates that even with complex agent debates, the system is efficient enough to be practical in daily trading or reporting by line. About the result, the agent produce a structured markdown report, each auditable on its own for fundamental, technical, news, and markets. These are consolidated into police and Paris perspectives, then into trader recommendation and risk-adjusted stance. The result is a transparent chain of reasoning from raw data to final decision. This significantly enhanced explainability and trust compared to a black box AI system. To conclude, we introduce a multi-agent and functional framework tailored for Vietnam market. The benefits are automation, transparency, and robust risk control. This application in both trading and back office tasks. The main limitation today is they rely on external API, which is slow down response time. In the future work, we will integrate a local database layer to speed up analysis and reduce the dependency on external source. Thank you for your attention. The Pinterest agent system is open source and available on GitHub. I would be happy to take your question now.
Thank you very much. I have one question. Did you use any artificial intelligence methods in your research?
I use LLM's large language model in our research to build our agent. We have 8 agents in this system. Like you see on the architecture, we have fundamental analysis, technical, news, market, police, trader, and manager. All of them is a LLM's large language model, and we build them as a agent in a multi-agent architecture. And to be specifically, we use GPT-4o Mini in this research. That's from OpenAI. Yeah.
Okay, thank you.
Yeah, thank you.
Are there any other questions or comments or recommendations? If there are no questions, I think we can go further.
Thank you for the presentation. Moving
you,
forward
thank you.
to the next presenter. We have Uma Sankari A with the paper titled Predicting Modeling of Customer Churn and Personalized Subscription Recommendations for OTT Platforms.
Am I audible, ma'am?
Yes, you're audible.
Yeah, okay. Just 2 minutes, I'm sharing.
Yes, you can share your screen.
Is it visible, my PPT?
Yes.
Yeah. Okay. Good afternoon, everyone. My name is Uma Shankari, and it's my privilege to present my research on predicting modeling of customer churn and personalized subscription recommendation for OTT platform. This work was carried out under the guidance of Dr. Kavita at VIT Chennai. OTT platforms like Netflix, Amazon Prime, Disney Plus, Hotstar have completely changed the way we consume entertainment. Instead of waiting for shows on television, people can instantly access movies, series, documentaries, and sports events also. But while the has been exponential, there is also a hidden challenge that these platforms struggle with, and this is the customer churn. Customers switch between platforms very frequently and leading to the significant revenue losses. So, okay. So here is my agenda. So first I will start with an introduction to OTT platforms and the churn problem. Then I will clearly state the problem statement and objectives of this research. After that, we will move on to the literature survey, where I will summarize what past research has done in churn prediction, and I will explain the existing system and their limitation. Then I will describe the proposed system along with the architecture and modules. And then I will show you the result and output, including the performance metrics. Finally, I will conclude with the contribution and future work. So this is the roadmap will help you follow the of research as we go deeper into the each section. So the introduction. So as we know, OTT, which stands for the over the top, refers to delivering the streaming media content directly over the internet by passing traditional cable or satellite television. So the OTT industry has grown into an incredible pace in the past decade. For example, Netflix alone has more than 260 million subscribers worldwide. So Disney Plus Hotstar also 150 million users within just 3 years of a launch. In India, Hotstar and Amazon Prime are the household names with millions of active users. But here is the challenge. The OTT industry also faced the highest churn rate in the subscription economy, typically between 35 to 40% annually. This means that out of 10 customers, 3 or 4 will leave within a year. For business, this is a catastrophic because customer acquisition cost is very high. Studies shows that retaining an existing customer 5 to 7 times is cheaper than acquiring a new one. So, churn prediction become a critical survival strategy for OTT providers. Not only that retention efforts, like personalized recommendation like discounts or offer can directly reduce churn. This is why churn prediction combined with the recommendation system is so important in today competitive streaming industry. So there is some problem statement required. Let's now look at the problem statement. Currently, OTT providers struggle to accurately identify customers who are about to leave. Existing churn prediction solutions offer it's like too simplistic, like using the logistic regression or decision tree, which don't capture complex patterns. And another one is too generic, not tailored to the OTT domains, where user behavior, binge patterns, and content preference matter a lot. Another big limitation is that churn prediction and recommendation system are treated separately. Predicting churn alone is not enough today. Once you know someone might churn, the platform need to take action. This is very much important, like suggesting a cheaper plan, recommending trending content, or offering a loyalty discounts. So the core research problem is, can we design a robust mission and deep learning based system that only predicts the churn but also recommend the personalized subscription plan to retain the users. So now move on to the objective. So my objective is churn prediction. So first we need to develop a model that can identify at-risk customers before they leave. Use multiple data sources like transactional history, usage behavior, and customer support interactions. And then second one is personalized recommendation. Instead of generic offers, suggest specific subscription plans that match the customer usage and churn probability. For example, if a customer on a premium plan rarely use the services, the system can recommend downgrading to a standard plan instead of losing them completely. The overall outcome is reduced churn and improved retention and higher customer satisfactions. So I studied there are so many papers. Here I will put 5 papers. Each research used for logistic regression and decision tree because they are interpretable, but their accuracy was very limited. Then came to ensemble methods like random forest, gradient boosting, and XGBoost. These significantly improved prediction accuracy are now considered strong baselines. More recently, deep learning models such as artificial neural network, LSTM, and CNN hybrids have been applied. These models are powerful at capturing the sequential and behavioral features like binge watching session. Some studies even attempted hybrid approaches, combining like ML with the recommendation system. So one important thing insight from the literature is that behavioral and engagement features such as watch time, frequency of login, or binge patterns are the strongest prediction of churn. But the literature also show the some major gaps, like very few public OTT datasets are available, which limit it reproducibility. Most deep learning model are accurate but not easily interpretable. Integration of churn prediction with the personalized recommendation is still unexplored. So there is some existing system in this project. Let's now look at the existing system used by OTT providers for churn prediction. Currently, most platforms rely on traditional statistic method like logistic regression or basic decision tree. These models are good at explaining relationship, but they fall short when complex large scale behavioral data. For example, logistic regression might capture a simple rule. Say, users who stop watching for 30 days are likely to churn. But in reality, churn is influenced by multiple factors like viewing the time, content preference, subscription type, complaint to customer support, and even competitor offering. Traditional models cannot capture these interactions. Another limitation is a lack of personalizations. That means customer churn prediction system may identify a customer at a risk, but they do not provide a customized strategies to retain the customers. And finally, these existing models often fail to integrate multiple data sources. For instance, transactional data is analyzed separately from customer support, ticket or content usage data. This fragmented approach limits their predictive power. So now I'm going to tell the proposed system. So our system integrated three different data sources. So one is transaction history, and another one is customer support interaction, and third one is content usage of data. By combining these three, we have get 360-degree view of the customer. Once the churn prediction model identifies a risk customer, the system automatically triggers personalized retention strategies. This could mean suggesting a lower cost subscription plan, offering a temporary discount, recommending a highly engaged content similar to what the users already watched. So, the expected impact is significant is improved churn prediction accuracy, more effective individualized intervention, and strong long-term customer loyalty. So, this is my in architecture diagram for my overall project. So the process begins with the data collection model, where information is gathered from transaction supports log and content usage. And the next is data pre-processing model. Here we clean missing values like normalizing the futures, balance the data set using the techniques like SMART, and prepare the data for analysis. Then come the predictive model module. This is the core where machine learning and deep learning and GNN are applied to predict churn probability. Once churn is predicted, the recommendation module take over. Based on probability and customer profile, it suggests either subscription changes or personalized offer. Finally, the evaluation model ensures reliability. It measures accuracy, recall, precision, F1 score, and compare performance across models. This pipeline ensures we don't just predict the churn, and we also take a proactive steps to prevent it. So breaking down further, the system is divided into five key modules. The data collection module first. So it fetches here data from raw input, transaction usage logs, and support records. And then another thing is data pre-processing models. It will clean the data and handle missing the duplicates. And then third thing is predictive model. It will apply the ML and DL model in this model. And then recommendation. It uses similarity measures and reinforcement learning to suggest personalized subscription strategies. And then evaluation model calculate the metrics like accuracy, precision, and recall, and F1 score. Each module is designed to handle a specific responsibility, and together they ensure a seamless and end-to-end workflow. And then churn prediction module. In the churn prediction model, we applied and compared several models. So first one is random forest and XGBoost. So these ensemble models worked by combining multiple decision tree. They are strong baselines and handle large future set wells. And then second thing is LSTM model. Since customer behavior is sequential, for example, watching patterns across week, LSTM is effective in modeling time dependent futures. And then third thing is GNN network. This is the most advanced approach. We treat customers or nodes with the edges formed by shared plans or similar viewing behavior. GNN leans churn probability through message passing between nodes, which captures hidden relationship between the other models and miss. So our experiment shows the GNNS achieves the highest performance. The accuracy is 92.60 percentage, and the precision recall is balanced at 92 percentage, and the F1 score is 92 percentage. So this demonstrated GNN are powerful in capturing the both individual and relational feature in churn predictions. And then next we go to the recommendation module. So now churn prediction is useful, but without action, it doesn't help the business. So that's where recommendation module come in. We implemented two approach. One is cosine similarity based recommendation and another one is DQ1. So in cosine similar based recommendation, customers are grouped based on churn profiles. If two customers have similar behavior and one choose a particular plan, the same plan is recommended to the other. It's simple but effective for a burst and personalization. And DQ1, a reinforcement learning agent, is trained to recommend the most suitable subscription plan like basic, standard, or premium. The agent receives reward for retaining customers. So over time, it learns optimal strategies. And like similarly, DQ1 is adaptive and work in real-time environment. This dual layer approach ensures recommendation are personalized, dynamic, and retention focused. So at last, output and result. The output from our system can be summarized in three levels. So first one is predicted churn rate. So every customer receives a churn probability score. For example, a customer A may have 70% of churn, while customer B has only 20%. So now we are going to give the personalized recommendation based on customer A and customer B. Based on churn probability and usage profile, the system suggests either subscription downgrades, upgrades, discount, or content recommendations. Now performance metrics. So GNN outperformed Random Forest, XGBoost, and LSTM, achieving the highest accuracy and balanced recall precisions. So it's a long-term impact. It increased the customer lifetime value. It's more important. And another thing is higher probability due to reduced churn. And then third thing is sustainable subscription based on growth. So these are the executable version of the software I'm used in here.
Sorry
So
for
in the
the
component.
interruption. This is a gentle reminder to conclude the presentation.
Yeah, okay. I'm just go to conclusion. So, churn prediction is not just an academic exercise, it's a business necessary for OTT platforms. So, in traditional model provided limited accuracy. Like NSML methods and deep learning improve performance, but GNN deliver the better result. Adding a recommendation module ensure the churn prediction is followed by actionable steps, creating a real value for business. So, our model offers OTT providers a competitive advantage, allowing them to interfere before losing the customers. In future, this work can be extended with explainable AI for interoperability, federated learning for privacy, and real-time adaptive pipelines. Thank you for your attention. I had to happy to take your questions now.
Thank you very much for the very interesting presentation. As I saw, you used neural networks. What type of neural networks did you use? For example, recursive, non-recursive?
No, I used here is a graph neural network. So it will help the customers as a node and their relationships as a edges. I already told, for example, two users who watch similar content or belong to the same plan have a connection. By passing message along these edges, GNN learn a hidden relational pattern that improves churn prediction beyond individual behavior alone.
But do you know the name? Because there are many neural networks. Or
What that?
which type of neural network exactly? Or
Uh,
many of them?
It's a look like a deep learning model only. There's a relationship between the customers and business.
For example, Hellman or
Uh,
is
can
it
you tell?
recursive or not recursive?
It's recursive only.
Recursive, okay. Thank you.
Thank you.
Are there any other questions, comments? If there are no questions, I think we can go further.
Thank you for the presentation. We'll be moving forward to the next presenter. We have Anant Chiraguri with the paper titled Strategic Media Insights on Video on Demand Platforms Through Graph Analytics.
Yeah, thank you. I'll just share my screen.
Yes.
Okay, I hope you can see my screen and you can hear me.
Yes.
All right, thank you. Good afternoon, colleagues and panel moderators. I'm very happy to present our study over here. I'm Anand Chiroguri. I'm the presenter, and I'm very pleased to present, this study, which was conducted by Dr. Goodall, along, with and me, along with other undergrad students. Okay, so we are from the United Arab Emirates University, which is in Al Ain, UAE. The outline, before I get to the outline, our, the topic is basically, the dealing with, the strategic, the media analysis, and the, idea is to analyze the data, with a new technique called graph analytics. So that's what we did, because this hasn't been used, earlier a lot. So we, believed, that the use of this innovative technique could actually, create more value. All right, having said that, let me move on to the outline. I will first talk about the research motivation and explain a bit about the methodology, talk about the data, approach, the pre-processing stages and so on, and then show you the results along with the limitations of the study, and then conclude with the the summary of the findings. All right, now when we talk of, the earlier presentation, coincidentally was talking about OTTs, over the top platforms, which is a broader term. They were talking about customer churn. So our study is, about a subset of OTTs, which is, VODs, video on demand. And, and one of the reasons why I guess customer churn could, happen is because of content as well. It's not just about pricing all the time. It could also happen because of content. So anyways, coincidentally, our study, comes close. We focus on, the content aspect of, these different VOD platforms. And, the idea is to see, if there are any similarities, between these platforms in terms of content, in terms of, strategies, something that is not evident. And so we use graph analytics for that. All right, so I just showed you, the picture of some, video on demand platforms. There are many, and they are based on different business models. You have Netflix and Prime, which are, based on subscription. It's called subscription VOD. And then you have YouTube, which is based on advertising, okay, advertising VOD. And then you have Apple TV, and also, the Prime, which is transaction VOD. So a subscription VOD, allows people to, to obviously watch a lot of content, using at a flat fee. Advertising is free. The content is supported by ads that you need to watch, and then transaction VOD is people. Now, when these platforms obviously generate a lot of data, a lot of customer data, and and also this customer data is related to what they watch, which is based on content. So there is a relationship between customers and content. But if you use traditional techniques, which are based on spreadsheets and databases and text, they do not focus on the underlying mechanisms, structures, which are hidden. The traditional techniques, the focus more on trends, which without giving us much context. And so, which is why there is a need for for a better technique or another technique that will give us a better perspective. So for this study, we have used graph analytics, which basically allowed us to analyze the media content across different platforms. And we have mentioned the ones that we have used: Netflix, Prime, Apple, Disney, HBO, Paramount. I mean, there are many. You also have Hulu and so on. But we used the platforms for which we had data. And we focused on the subscription via the video on demand, because it's the most popular one. And our objective was to profile these platforms and benchmark, to see which ones are different or similar, and then also explore things about the content along with the ratings. As I mentioned before, graph analytics is less used, so that's our contribution. Our contribution is not only in terms of methodology, which you see over there, but also we we aim to contribute to the domain knowledge. And we have recommendations. Our study will have recommendations for that can be used by practitioners to to study more, examine more research areas. So graph analytics is not new. It has been used in large data sets to find relationships. It does not replace machine learning or databases, but it is more specific. And we used graph analytics for this study because our study was about relationships and networks. I just mentioned about consumers and content. So obviously there's a relationship between what consumers see and we, our idea was to, basically, to look at that and see if there are any patterns. Now, one could argue, that we could also use databases to do the same thing. But, if you use databases, you're using a lot of tables, and these tables have to be, joined by using foreign keys. And so if you're running queries, you're, talking about combining lots of tables, which basically slows down the performance, which is why, graph analytics is preferred, because it's more efficient when it comes to performance. And also, well, it's a, proven technique, reliable technique, to find hidden patterns in relationships. I mean, you also have a similar approach in, unsupervised learning, K-means clustering. I mean, which also, groups data into groups, but, but it does not focus on relationships, which is why this technique is better. For the purposes of this study, we got data from, Kaggle, and, we used, we took the data set from, Kaggle, different data sets. We, merged them, and then we, obviously that's all part of data pre-processing, and then we ran the a priori algorithm to find patterns, which was then converted into a data set to find the strength, and based on that, we created the graph. So our results, the one we looked at platform popularity, and if you can see these lines, over here, the black lines, it basically shows that. Amazon, has, some, I mean, it has got content, but Netflix has even more content than Amazon, and then Paramount seems to have the least, the content. So, basically, this is, telling us that, there are some factors, obviously content is one of them, which could, basically, impact, why consumers prefer certain platforms. Okay. Then we also, focused on, excuse me, sorry about that. We also focused on, the common content, and what we saw was obviously these OTTs are or video on demand, platforms are represented as nodes. You can see the centralized nodes, and while the content, Netflix at the bottom has a lot of content, and it's pretty much exclusive, and that makes sense because Netflix has been investing billions of dollars in content development. But these platforms also share some content with other platforms, okay, which is interesting to know. And so our analysis also showed the common content across platforms, which, as you can see, is not much, but it is there. I mean, there are some exclusive agreements. Moving on, we also, our analysis also showed the type of content which is more popular on these platforms, and R-rated content, perhaps because of the violence or because of the themes, was more popular, followed by the PG, parental guidance. Our analysis, also, showed, that some platforms were closer to each other when it comes to content. Well, you have Disney, and then you have Netflix. They were close to each other, and while it would seem they don't have too many common titles, but the quality of the genres that they deal with makes them closer, and that was captured by the technique as well. And finally, we also, I mean, this is just an example of how we use the technique to profile platforms. We saw that, I mean, we used it on Paramount, which had the least, amount of, content, and it showed that Paramount, was, investing in both, family, family-friendly content as well as on, in our content. So, so obviously they were trying to position themselves, separately for different groups. Um, so obviously, so our study, using the technique of graph analytics showed all these relationships which were not possible earlier. But obviously, like any other study, this is not perfect. There are limitations. There could be other variables, and we got the data set from Kaggle, and which could, which could have had a lot of noise. But we did do our best in the data pre-processing stages to get rid of as much noise as we can. So through the study, we wish to show graph analytics as a viable tool to benchmark and analyze the content, especially when you are dealing with relationships. And very few studies have done have followed a similar approach, so that makes our study valuable. And yeah, and I hope other researchers and practitioners can use findings from this study and then come up with elaborate strategies. Okay, so thank you. Any questions?
Thank you very much.
Thank you, Dr.
Yes.
Zlatinka.
Yes, I saw you are using graph analysis, graph techniques.
Yes.
And did you try some artificial intelligence tools?
Okay. I mean, I could try some artificial intelligence techniques as well.
Yeah,
Is that
yeah,
what
I
you're...
think.
Yeah, absolutely.
For
I
future
mean,
development. If you
absolutely,
didn't use it
absolutely.
to this moment, I think that you can use them for the future development of the study.
No,
It's
absolutely. I think,
interesting.
this was, an exploratory study. We are, we could use the same data set and use other techniques to get, more, context. I mean, it's all about context and not just about, data, and that's what we'll be, looking at. So thank you very much. Yes.
Okay. Are there any other questions or suggestions?
I also have Dr. Goodall, who is the co-author, and he has been listening to the presentation as well. So I thank him as well for his time, and I thank everyone for their attention. Thank you.
If there are no more questions, I think we can go further.
Yes. Thank you for the presentation. We'll be moving forward to the next presenter and the very last presenter for the session. Kinjal Bhatia with the paper titled The Grammarly Effect, a Mixed Methods Study on the Impact of Instantaneous AI Feedback on Student Writing Anxiety and Revision Processes.
Yes, ma'am. Okay, hope the screen is available.
Yes.
Okay. Yes. Thank you. Good afternoon, everybody, respected chair, distinguished scholars, and fellow participants. I'm Dr. Kinjal Bhatia from Charotar University of Science and Technology, Gujarat, India. It is my privilege to present my paper titled The Grammarly Effect, a Mixed Method Study on the Impact of Instantaneous AI Feedback on Student Writing Anxiety and Revision Processes. So being an English professor in a university in the past decades, we have witnessed this unprecedented integration of artificial intelligence into the education. So tools like Grammarly, Pro Writing Aid, and even built-in AI editors in Google Docs, Microsoft Words have become nearly ubiquitous companions for the students. So these tools promise instant feedback, catching errors in spelling, grammar, punctuation, even in style, and they are often celebrated for making writing cleaner and more professional. But the question that I have raised here is, what are these tools doing to psychology of the students and to the very process of writing itself? So while much of the research so far has focused on error reduction and efficiency, my study here explores the hidden psychological and pedagogical consequences of using AI feedback. So this phenomena, which I call the Grammarly effect, is paradoxical. It reduces some anxieties while creating the new ones, and it streamlines the revision while sometimes undermining the authentic learning too. So that is what my research says. That is the background of the research says. So the research problem is very clear. The gap is in literature, which we can say that Grammarly and similar tools which we have that reduces surface level errors, but we know far less about that. Their impact on writing anxiety, a well-documented barrier that influences students' performance. So their influence on revision processes, whether students are engaging in deeper thinking about the structure and argument, or simply just clicking the accept without reflection. So many a times we have seen that there is an underline, the spelling that has been incorrect, and that is an underline which shows that the spelling is incorrect. We can right click and we can just make it correct, but does it just engage us in deeper thinking about, are we learning, or are we just coming up with the things which is clicking it out without any reflection to this? So that is what the research says. These are the research questions which I have posed in my study, that says, how does the instantaneous AI feedback affect the level and nature of writing anxiety among undergraduate students? How do students interact with and apply AI generated feedback during the revision? And how are these anxiety experiences and revision behaviors interconnected when using AI tools? Okay, so this is the theoretical foundation that I'm working with. So first, that writing anxiety research, which shows that anxiety manifests cognitively and affectively behaviorally. AI tools are very unique position to address one dimension, that is fear of grammar and mechanics, but they might create others. They can solve one of the, I'll say, problems that students may face, but they create a few errors in students' learning process also. So second is revision process theory. Research distinguishes between the surface level correction and deep rhetorical revision. Novice writers tend to focus on low order or lower order concerns, while experts address global structure, that is argument and audience. So the question is, where does this Grammarly push students towards the deeper revision or towards this superficial fixes? So that is what it is my theoretical foundation says. Then comes the study and design, that is the methodology. So this was a sequential explanatory mixed method study conducted at my university where I'm working, that is in Gujarat. There are total 124 first year BBA students, which were randomly divided into two groups, one who uses Grammarly and the other is without it. So the phase one that goes with all students completed the writing apprehension test before and after the intervention. And they also produce timed argumentative essays. In the phase two, which is called qualitative version of the same, that is a purposive sample of 15 students from the Grammarly group participated in Think Aloud writing tasks and semi-structured interviews. And this design has allowed me to measure broad patterns statistically and then dig deeper into the lived experiences experiences behind those numbers. Now I'll focus on the findings more. So this is what the slide looks like when I'm talking about qualitative and quantitative outcomes. So the results confirm some of the expected benefits, like writing anxiety that scores in the Grammarly group dropped significantly from 78.5 to 69.1 on the writing apprehension test. Essay written with Grammarly had far fewer surface errors, about 1.8 per 100 words, or compared to 4.6 in the control group. So these differences were highly statistically significant. So on the surface, the tool works. But if you go for qualitative insights, the deeper picture is more complex. Two themes that emerge as delicate revision. Students often accepted Grammarly's suggestions uncritically. Phrases like, I'm not sure why this is wrong, but I'll just click and accept were common. So revision became more about efficiency rather than learning. So this double-edged nature of confidence. On one hand, students reported relief that they no longer worried about this constantly, about the tenses, articles, spellings. And on the other, the new anxieties emerged. Some began doubting their voice, authorial voice that they are having, or especially when Grammarly flagged complex sentences or stylistic choices as wordy or unclear. In the other words, relief from grammar and anxiety gave rise to conceptual anxiety, a worry that their own ideas and style might not be just good
Kinjal,
enough.
Kinjal,
Yes.
excuse me, Kinjal.
Yes,
Kinjal,
yes, yes.
I have one question regarding this. How does
Yes, ma'am.
artificial intelligence affect the student writing skills? Can you give some example for that?
Yes, ma'am. When we have given them the choice to write on their own, and we have asked them to go through the AI, majority of the students were not confident on their own writing. They were having more reliability on the AI that they are using. They were doubting themselves that we may not be able to write the proper version of whatever we are knowing. Again, the choice was like when they were given choices on spelling corrections. So they were not sure of two or three spellings if they are having. They were not able to choose which one is the correct version of the spelling that they are writing. So there were this paradox of this Grammarly effect is very critical. On the other one hand, they just click on the right and accept the suggestion which is given, which is unclear or which is wordy. And in the other words, relief from grammar anxiety gave rise to conceptual anxiety. Okay, so on the one side, they are relieved that their grammar, their spelling, their punctuation errors can be taken care of by AI. But on the other hand, there is a conceptual anxiety that has arisen that their own ideas and style might not be good enough. So this one of the thing that we have observed in the students, and this is what the results look like. So that delegated revision that I've talked about, and this double-edged confidence that we are talking about. So this is the effect that we have gone for, the very mechanism that reduces this surface level anxiety, that is namely said as delegation to AI, that fosters dependency and that undermines autonomy. So students gain relief from the kind of anxiety but develop the other. So the subtle insecurity about their intellectual expression, I'll say. So this raises the profound questions for the pedagogy that we are utilizing, that are we training students to write or to outsource the writing decisions to algorithms that we are creating? So that goes in this, and this is the implications that we can work on. For educators, we can promote critical AI literacy. Students should be not taught to blindly accept the AI suggestions, but to engage with them critically, asking why this change is suggested and whether it serves their rhetorical purpose or not. For developers, we can talk about AI tools should move beyond click to fix. Okay, instead of acting as oracles, they could adapt a more Socratic design, posing questions and scaffolding learning. For example, why might this sentence be hard to read rather than simplify flagging it as wordy? Okay, so only through such strategies can AI be integrated as collaborator in the writing process rather than as a silent authority that we are having. And this is the I say limitations of my study, that goes that, of course, the study has certain limitations. It was conducted within one situation, one institution, one with only management students, and that too in India. So broader studies across such disciplines and cultures which are needed. Future research might also explore some long-term effects of AI dependency and compare alternative feedback designs. And this is, we can explore to the further limitation is there. And the future direction, I'll say to conclude that the Grammarly effect is not just a simple case of technology being good or bad. It is a paradox. On one side, it reduces our errors, elevates grammar related anxiety. But on the other hand, it fosters passive revision habits and may undermine authorial confidence. So this research underscores the urgent need for balanced approaches, both pedagogical as well as technological, and that empowers the students to harness AI as a partner in writing, not as a replacement for their own critical judgments. So this is what my study says. Thank you very much for your attention. I'm looking forward to the questions or reflections.
Thank you very much, Ms. Bhatia, for the interesting presentation. It is a very good idea to apply artificial intelligence in students' education.
Yes. Thank you, ma'am.
You mentioned here Grammarly. Do you know any other tools?
Yes, ma'am. I have mentioned in my presentation that we are also having Pro Writing Aid. That is also one of the AI that works with works like Grammarly. We also have a few websites which directly give you the I'll say suggestions regarding the writing that you have gone for. We have both other AIs which work on the same part.
Thank you. Yes, I really recommend you to continue applying
Thank you,
artificial intelligence in the education of students.
Yes, thank you, ma'am. Thank you.
Are there any other questions or comments or recommendations? If there are no comments,
So there are no more questions, I believe.
Okay.
Thank you for the
Thank you, ma'am.
presentation. Yeah.
Thank you.
So that brings us to the end of this session. We have completed all our presentations for this session. So I'll just quickly give the closing remarks. I sincerely thank all the presenters for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for you all. We, on behalf of the whole team, we thank you for your support during this version and all the previous 3 versions of the conference. And we'll be happy to have you in the 5th version in 2026 as well. All the presenters would be receiving their digital certificates through email within 2 working days. And the publication will be live within 7 to 8 months. So kindly cooperate with the team of ISBM 2025. I'd also like to thank our session chairs for chairing this session. This is a token of appreciation on behalf of the team of ISBM, Global Knowledge Research Foundation, and partners. So Professors Latinka and Professor Vijeta Kumawat. Thank you for your valuable presence, ma'am.
Thank you.
Thank you, ma'am.
I also want to thank all participants for the very interesting research which they presented to us. Actually, we shared many ideas to improve our future research and our life. All the presenters really contributed to this task, and I wish all of them great success in future.
Thank you so much for your kind words, ma'am. Now we'll be ending the session, and I'll just request you all to please turn on your cameras for a quick snapshot. Okay, thank you so much, everyone. We'll see you again with us. Take care.
Thank you.
Thank you, ma'am.
Thank you.
Thank you so much, ma'am.